Hello world, this is Rick Sanchez and today we're going to solve the April challenge 2 in 2020 division 2, that is COVID pandemic and long queue. So it is given to us that due to the COVID pandemic, people have been advised to stay at least 6 feet away from any other person. Now people are lining up in queue at the local shop and it is your duty to check whether they are all following this advice. Okay, so there are a total of n spots numbered through 1 to n, where people can stand in front of the local shop. The distance between each pair of adjacent spots is 1 foot. Now each spot may either be empty or occupied, and you're given a sequence a1, a2, an, where for each valid I, ai equal to 0 means that ith spot is empty while ai equal to 1. Means that there is a person standing on this spot, it is guaranteed that the queue is not completely empty. Okay, so it is given that we are given n spots numbered from 1 to n and people are standing in these spots. Okay, now the distance between each adjacent spots is 1 unit. So consider this example, n equal to 11, we are given n11 and we'll be given 11 spots. So 1 2 3 4 5 6 7 8 9 10 and 11. Okay, so within these 11 spots, the spots where the value is 1, people are standing there, and the spots where the value is 0, people are not standing there. So in this case we have 1 2 3 people standing at indexes 1 2 3 4 5 6 7 and 10. So in this case, as the minimum distance to be safe is 6 feet. So the distance between this person and this person is 1. So it is 7 minus 1, that is 6 feet. So these two people are safe, but this person and this person, the distance between them is only 2 1 2 3 3 units. So these two people are not safe. Okay, then this is a queue in which people are not following the advice. Okay, so if we find a queue where people are not following the advice, we're just going to say no. Okay, and if people are following the advice, we're going to say yes. Okay, now we need to determine whether or not the people outside the local shop are following the social distancing advice or not. As long as some two people are standing at a distance smaller than 6 feet from each other, it is bad, you should report it, since social distancing is not followed. So let's see the input. So I think you got the point. The point is there are n spots outside a local shop, and in these n spots are marked 1 feet apart. In these n spots people are standing, and two people are safe if the distance between them is minimum 6 feet. Okay, so there should not be a person standing less than 6 feet away from each other. Let's see the input. Will be given an integer t, which is the number of test cases. Okay, and the first line of each test case contains a single integer n. So will be given t, will be given n, and then will given an array of n numbers. Okay, n integers. Now we need to find out whether the social distancing is followed or not followed. For example, this is the example input. We have three test cases. So one, this is the first test. So this is the three test cases are there. Now the n is 3 in the first test case. The array given is 1 0 1. So the distance between them is 0. 1 2 units. So this is no, because minimum distance should be 6 feet. In the second case, there are 7 spots. People are standing on the spot 1, spot 0 and spot 6. So the distance between them is 6 feet. So I think this should be yes. And in the next case, there are 11 spots. The people are standing at spots 1, 7 and 10. So as you can see, these two people are safe, but this person and this person, the 7th and 10th, this is not safe. So because the distance between them is 1 2 3 3 feet only, and minimum distance to be safe is 6 feet. Okay, so As you can see, it's also explained there. So let's see how we can solve this. Okay, so first I'm just going to okay, I'll just write out the structure and then I'll explain how to do this. Okay, now first we have the integer t as input. So how are we going to solve this? So what I would do is, for each person I would find the indexes at which they are standing and I would note down their indexes. So in this case, suppose for in this example, the indexes where people are standing are 1, 3, 4, 5, 6, 7 and 10. So 1, 7 and 10. So 7 minus 1 is what? 6, but 10 minus 7 is what? 3. So for example, if I just copy this test case, yeah, so the indexes here are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So I'm going to find out for this particular case, I'm going to find out which index is having the person standing on it. So which spot has the person. So in this case we will have a person is standing at index 1, at index 7 and at index 10. Now we need to find out whether this whether this social distancing is safe or not. So in this case 7 minus 1, these two people are safe. So 7 minus 1 is what? 6. And in this case these two people are not safe because 10 minus 7 is 3. Now how do we store these? So we need a way to store these indexes first, and then for example, let's store these indexes in a vector, and then we'll iterate over that vector and we'll see how we can calculate the distance between them. Okay, so let's take the input first, and when this is there we are going to take n. Now we are going to take the input, the people standing. Okay, so we know that the input can either be 0 or a 1, right? There cannot be any other input. So let's also have another data structure. Let's have not a data structure, but let's have another vector defined. Let's call it spots. Okay, now we know that this a of I, the people can either be 1, they can be standing, or they can be not be standing. Either the spot has a person or the spot does not have a person. So if the spot has a person, okay, we'll simply put that index spots dot pushback in this vector. Okay, this is clear, right? We are taking t integers and number of test cases, and for each test case we are taking input as n. We are doing, okay, I haven't defined the array here now. Okay, we are taking n, we have defined an array of size n, and we are iterating through that, and we are taking input. Now if a of I is equal to 1, we can also just leave it like this since it means true. So if a of I, then we'll push it back to the spot. And now once this is done for each test case, what are we going to do? We are just going to calculate I plus 1 minus I. If this value is greater than 6, we know that the person is standing there. If this value is if we know that the social distance is safe there, but if this value is less than 6, the social distancing is not safe. So 10 minus 7 is 3, which is not safe. So in this case we are going to print no. Okay, so let me just comment this out, and let me also include vector. Okay, now Now for I'm going to iterate over the vector, and I'm going to find out if spots of I plus 1. So if this is I plus 1, this should obviously be minus 1, because when we are at the last index, we if we go here, it will give us a out of array, or segmentation fault if we are trying to access memory that is not there. So spots of I, okay, if this is uh, greater than 6, right, greater than or equal to 6, okay, we are just going to say now for this case flag will be what, 1 if this is less than 6. I'm sorry, initially it is 0, we have flagged it, that means it is not safe, okay, and this will go on. So for example, we have input as this, suppose this is our input, let me just copy it here just to show you. So if this is my input, my vector will look something like this: 1, 7 and 10, okay. Once I have this vector, I'm going to iterate over this vector. My I is first here, then I'm going to find spots of I plus 1 minus spots of I, which is 6. This is not less than 6, so in this case flag is fine. Then I moves here, spots of I plus 1 is 10, minus spots of I 7, which is 3. That means our flag will be 1 here, so we're just going to flag it. That means this is not safe. Now we'll check. If we have the flag, we are just going to print no. Otherwise, if we do not have it, we are going to say yes. Pretty straightforward question. We just had to store the indexes and print it. So we will try this out. Okay, I hope everything is fine here. Let me just erase this and this, and let me just copy everything. Yeah, let me just copy this input here. Okay, okay, let me try, and okay, let me just dry run it once. So we have T, we have spots. Okay, if we are getting a 1, we are pushing that index here, we are initializing a flag as 0, and for each element in spots array, that is the indexes where people are standing, if spots of I plus 1 minus spots of I is less than 6, we flag it. That means this is not safe. Let me just write a comment, not safe. Okay, now if the flag is not, if the flag is set, that means the social distance, then distancing is not safe. We are going to see out no, otherwise we are going to see out yes. So let's try and run this. Where am I? Okay, let's just do, okay, okay. I'm here. I want to go to CodeChef and April something. Yep. Okay, now I'm going to compile this. So let's try to submit it. Okay. So instead of IO stream in my computer, I had C++ no, I did not have C++14, so here I'm just replacing it with bit/stdc++.h, and everything else is the same. We have taken a vector, we don't need this iterator. So we have taken a vector, we have taken a t input. Now we're going to run this with the given input, okay, this input. Now let's see what happens. Okay, so we get no, yes, no, which was expected, and as you can see we get the correct answer, right? So this is how we solve the COVID pandemic and long queue challenge on CodeChef for the April challenge. Them down in the comment section below. So this is a few of my first videos, so I would request all of you to either share it or show some support so I can make more videos and I can maybe go from go from solving all the challenges in future for you all. So thank you so much for watching this, and have a great day, and stay safe from the coronavirus. And again, this problem teaches us to stay at least 6 feet away from each other. Okay, so have a good day, guys. Bye bye.
Corona go! Corona go! Go Corona! Go Corona! Corona go! Corona go! Go Corona! Go Corona! Go Corona! Go Corona! Go Corona! Go Corona! Corona go! Corona go! Corona go! Corona go! Corona go! Corona go! Go Corona! Go Corona! Go Corona!